Thanks everyone for joining. This is a panel that is part of a larger workshop that's focusing on rising stars in data science, and it's hosted by the Center for Data Computing at the University of Chicago. This is going to be a really exciting panel focusing on interdisciplinary data science research and talking a little bit about some of the different ways that people are working together, some of the work that is happening that's very interdisciplinary. And you can ask a lot of questions about how does that actually function? How does that work in real life as a researcher, as a faculty member? So I think this will be a really great introduction. So I think, let's see, do we have our moderator on the line?
We do.
Okay, great. So Eamon, thank you so much for moderating this panel. I'll kick it over to you so that you can introduce yourself and the panelists if you'd like.
Okay, excellent. Thank you. So I know that one of our panelists is currently a moderator on another panel that is taking place in another institute on campus, and that is wrapping up right now. So he just sent me a text message saying he's on his way in. That's James Evans. So
that's just a classic example of how many exciting data science panels and activities we have going on at U Chicago at any one time, right?
I think that's right. So what I'll do is I won't stall, but I'll just slowly kind of introduce myself, introduce our two panelists that are present, and then hopefully by that time James will be in here. So hi, I'm Eamon. I'm really excited to be on this panel. I'm a philosopher of science, so I actually come from the humanities, but I do a lot of work in the computational social sciences, and I think what we're broadly referring to in this series of talks as data science. Here's James, so we're all set. Our co-panelists or our panelists for this are Professors Marshini, Chetty, Luís Bettencourt, and James Evans. And what I'm going to do is I'm going to have each of them in that order introduce themselves, tell us your position here at the university and what your primary researchers are, and then we'll just jump into a conversation about interdisciplinarity in data science. So, Marshini?
Great. Thanks, Eamon. Thanks, everyone, for inviting me to the panel. So I'm an assistant professor in computer science here at U Chicago, and my primary research area is actually in human-computer interaction. That's my subfield. And I have participated in a lot of interdisciplinary data science work, but mostly coming from a human-computer interaction or human side of things angle. Great. I'll pass it on to Luís.
Luís, are you muted? I think you're muted, but.
Oh, you can't unmute yourself?
Right. Okay, good. Hi, everybody. Sorry about the glitch. My name is Luís Bettencourt. I'm a professor of ecology and evolution and also associated with sociology on campus. I came to the university about 3 years ago to direct the Mansueto Institute for Urban Innovation, which is about urban science. So you can have it all. My work is mostly in the area of complex systems. So it's how all these things come together to form a system that's dynamical, that changes, that learns, that evolves. And so, from the beginning, I was trained also as a physicist. My interest has always been in problems where, new data resources come together with interesting questions. And in some sense, a lot of my work and a lot of the work that we try to promote with the Institute is really sort of a 21st century version, if you allow me, of the scientific method, right? How is it that we test and integrate the theories that we have of society, of humans, of nature into and create a system that's more predictive, but also to understand in theory what it could be like. So that's what I do. I'm very excited to be here, very excited about data science as gaining strength on campus.
So I'll take the ball from Luís, I guess. I'm James Evans. I'm a professor in sociology and I help run the Computational Social Science Master's Program. I started that program on campus, and a center called Knowledge Lab, which is really an attempt to take large-scale data about the world to understand how it is that individuals and collectives understand, and how to overcome limitations of individual and collective reasoning. And so as a result, I think, and we're using data science tools almost exclusively to do that work. And we're trying to kind of find ways to interact with kind of data scientific tools and other qualitative and quantitative techniques to both do a better job of kind of sensing what it is that people and systems know, and basically, supporting them with improvements that ends up kind of looking a little bit like human-computer interaction recommendations. So I end up interacting with a number of different types of groups, from humanities to finance and business to the natural sciences, where we spend a fair bit of time trying to kind of help them solve their collective problems and accelerate their discovery.
Okay, great. So we've got about 20 minutes for sort of internal panel discussion, and then we're going to open it up to some Q&A from the audience. And I think that a good way to kind of start this discussion, since this is a panel on interdisciplinarity, is how do you navigate this this tension between the disciplinarity that is sort of demanded of your discipline, of the peers in your discipline, what it takes to really be a computer scientist, or to be an ecologist, or to be a sociologist, and how do you take up the questions that are relevant to your discipline in a way that kind of spans disciplines. And the reason why I asked this question, because this is of course the work that you do, is that many of the people in our workshop today are junior researchers or junior scientists that are trying to navigate not only the sort of like intellectual and aesthetic norms of their disciplines, but also want to sort of broaden their interests, broaden the kinds of questions they take on. So how do you negotiate that tension where you are at once a sort of disciplinarian and at the same time a sort of master of none? So I'll go to Marshini first, since you've done some work in policy, which is, I don't think, sort of typical of computer science, and then we'll hear from the others.
Yeah, I think that it's very tough, but I think I always, I feel like you should play to your strengths. So as a computer scientist, I always start with a question that is rooted in computer science and my subfield of HCI. So if I'm asking something like, how do people watch videos on YouTube and understand if someone's advertising to them? I mean, there may be, a fundamental HCI kind of question. How do we show people this? How do we gather data to see if this is really happening, and so on, and make sense of it, and then create a system to help people at the end of the day? There's a lot of data science that went into that question, but I always sort of stuck with my strengths and my discipline, and then worked with others to fill in the places where I felt like I didn't have those strengths. And I think that can work across whatever sort of data science you do, is you bring what you bring to the table, right? And then you have to recognize where your limitations are, and then work with others who bring other strengths to the table to kind of make sure that you're addressing the problem in a holistic way. So even when it comes to, say, having policy impact, so I mentioned, we try to understand how people are watching YouTube videos and whether they're being advertised to, and if they recognize that. The policy impact was, we had to then take that evidence and then communicate it to the Federal Trade Commission. Now, I'm not a policymaker, but I could speak to things in terms that I understood with the language of computer scientists, and try to find some sort of shared language to communicate that to policymakers, but always sort of playing to my strengths, right? And I would say that's my advice, is play to your strengths, but then try to find other people that you can collaborate with who can sort of round off and help you address or, find a solution to a problem in a way that you couldn't do if you just did it by yourself as a computer scientist, right? So that's where you can get someone else from sociology or maybe the med school or whatever it may be, depending on the problem, to help you understand something that's bigger than just your discipline itself. I don't know if that's helpful.
Right, so I'll jump in. So I totally agree with Marshini that in some sense, I think collaboration is essential. And I think you cannot work in sort of fields that touch data sciences without, domain experts, method experts, people that are more computational and so forth. And also that we have to have distinct skills that we bring to the table. But having said that, I think that the thing that comes a little bit with that too is to have a good question, right? A good problem to work on, that people are excited, that can rally a group to collaborate. That's not so easy, actually. And that takes some time discovering what that is. But that is actually, to me, has always been the glue. And so I work on things like that, demand a question, answering questions like, how does a city actually work across, spatial, environmental, energetic, economic dimensions? How will that come together? How could you even imagine that? So you need a team of people to do that. Or how is biodiversity changing and how can we measure it from the ground, from a satellite? So these problems are very exciting. And so the shift here is that you start having sort of a problem-driven sort of kind of research. And whether you ask about a city, or if you ask about biodiversity, or you ask about climate change and sustainability, these don't really belong in any existing discipline, right? They ask for all of us to come together with different skills to kind of address these questions that are of great importance, that touch a lot of policy and strategy, but also that really are being enabled by data and data sciences, but where data is not quite enough, right? There are social and theoretical dimensions that go beyond what we can measure today. So the magic is in really kind of creating sort of teams that are dealing with problem-driven issues that are of motivating importance. And I think then it's sort of a work of learning how to do this together. And our skills also, our strengths keep evolving as we do this. So I think next time we can also address a different problem or a bigger problem or from a different angle. So that's sort of my experience. And if you are able to do that, then you just hit one gold mine after another, because the world's full of data and the world's full of great problems that are interdisciplinary.
So thank you. These are I really enjoyed these answers. Just a couple of additional takes. I think Marshini's first point about, play to your strengths, at least for me, I think part of the question is, so what exactly are your strengths? I think discovering your strengths, because I must say, I actually have hated the projects where I'm like pulled on as the sociologist, because I'm not the average sociologist, and I very rarely do or even like doing the things that I've been recruited for as the sociologist. I've been recruited in biomedical and other projects, and they always say that I should be interested and expert in things that I typically don't care about, or that so I think figuring out what it is that you like to do. So for me, one of the things that I like to do is I like to define projects that are bigger than me. So I like to think about, configuring these things, and then the project sounds amazing, and then I realize that I have too much ignorance. There's a bunch of pieces that are way beyond me, and so then I recruit, and I enjoy that. I find that fun, and so I think figuring out, do you like to design the projects? Do you have like a magic tool, that can apply to everything? Do you have what kind of imagination? What is it that you bring to the table? And I think once you figure that out, then you're able to lead these things rather than passively let opportunities, surface for you. A second thing that I think is related to this is that I think for interdisciplinary projects with diverse data, they are a gold mine. They're also, like a pit of failures. And so I think you actually want to be going after projects that have the potential to succeed and the potential to fail, because I don't believe that those are uncorrelated. If you can't fail, then I'm sorry, anybody could have done it, or it could have been, so there has to be risk involved. But if you're going after a project with risk, then you're a young person. You probably is advisable to develop a portfolio, even when you're young, of multiple projects, so that you're not kind of clinging to ones that are failing with your cold, dead hands. And I would even advise you to find ways to celebrate failure. For example, you're working on a project and you state from the outset, okay, here are the things that we expect, and we'll continue discovering if it's interesting. And if these things don't turn out, then we're going to celebrate the disbanding of this project with a great meal or a great, celebrate failure as well as success. Because if you can't do that, then it's very difficult to sustain a portfolio of projects. It's very difficult to be excited about risky projects if you can't learn to fail with grace and celebration. And I think finally, at least for me, is that you need to understand the publishing norms in different fields and the publishing expectations for the different collaborators on your team. So for example, if someone's going to try to get a computer science job or get promotion to computers in a competitive computer science department, then they need to play in these competitive conference things. But if they're collaborating with me, I value those things, but I also value a big, empirically challenging, multidisciplinary publication, in PNAS or Science or Nature. And so figuring out ways that you can satisfy everybody's demands and needs so that everybody can feel excited about these projects. So for example, typically the data demands for the big multidisciplinary paper that speaks to disciplinarians are much higher than they are for kind of like demonstrating the value of a tool, and figuring out really, synergistic ways that you can kind of satisfy everybody's incentives, I think is critical, and at least understanding them is critical for being able to empathetically keep everybody energized in the collective project. So
it seems to me that like success and failure is actually not the easiest thing at all to define, especially when you're trying to work across, certain disciplinary boundaries. So, for instance, like you just suggested that a publication for you in maybe even a very competitive computer science conference wouldn't necessarily satisfy the demands of your department, for instance. And so is the advice can't just be, play to your strengths if you're talking to a junior researcher. And so one of the, I guess that we actually have a great example on our panel. So Luís, I'm going to point out that your PhD is actually in theoretical physics. And your home department is ecology and evolution. So what do a bunch of successes for a young theoretical physicist look like, such that you end up in a ecology and evolution department? How do you navigate something like that?
Okay, so some of it is accident and luck, has to be said. Mm-hmm. But I think part of what can propitiate a bit of luck and success is, again, what I tried to express already, that look for interesting questions that people have been trying to discuss for a while, and whether they become resolvable or open up or gain a new perspective from new data or from new methods. And because we live in such a rich world of data and methods, often not devised to answer scientific questions, if you are able to do that across questions that are interesting, then that's actually sort of a meta skill, right? A bit like what James was discussing. It's not specific to a particular problem, but that's kind of a good recipe, I think, for success that will allow you to deal with a lot of problems. In my own path, you kind of take certain dimensions of what you learn in each discipline. And I think if you, it's easier to say in retrospect, but if you can kind of see how they connect, they give you actually a special place where you can be a translator, but also you can be this enabler of new things. So for me, I was, in some sense, in my time anyway, it was a place where you learn to do a really good mathematical modeler. You can deal with complicated world problems. You know how to do the math. You can know how to make it into something that you can test because it's a little model. And you can iterate this kind of process. And that's very useful in data sciences as well. It's not so common anymore, but that allowed me to kind of move into epidemiology actually first and do some work that this year, unfortunately, has been very useful, which is how do you do real-time prediction of a very messy process like an epidemic. And then that moved me into other social dynamics with richer data that then led me to cities. And because these problems were interesting and because somehow I was able to do new things every step I took, it took me from that place via ecology and evolution to study also a lot of cities today. But in some sense, it's keeping sort of being at the boundary of what you can do with data and mathematical methods at each step. And as long as what you do is occasionally, as James was saying, sort of interesting, catches somebody's eye, then I think you start getting a reputation for being sort of an interesting person. And that takes time, but after a little while, that gets easier and easier. And people kind of are interested in what you say, and it's easier to publish and so forth.
So I've got one more question, which follows on this, and then we're going to open it up to Q&A from the audience. So please feel free to raise your hands, type questions into the chat. So the answer that we just got kind of inverts the perspective a little bit. So we were talking about how we can use sort of the tools and techniques of data science to kind of move across boundaries, move across disciplines. But in what ways do you find in your work that it's actually the disciplinarity or the interdisciplinarity that informs data science? So it sounded like the kinds of questions that come from various disciplinary perspectives are actually such as to move the boundary of what's possible with data, what's possible with compute, what's possible with algorithmic approaches. So how do you in your own work find that it's actually the questions that you're asking outside of the space of data science sort of feeding back into and really accelerating and pushing the boundaries of what we can do with these kinds of tools and techniques? This is open.
I think it gets down to the question of just what is data science and why does it need to be interdisciplinary in the first place, right? I think it's because it's fundamentally a very human process, because a lot of data science, it's about, not just getting the data, but what do you do with the data when you get it? How can you make that data understandable to someone? That means you have to know the needs of the people that you're trying to serve. How can you interpret that? How can you explain that? How can you visualize it, right? And with just sticking with one discipline, surely you can sort of address some of these questions. Like maybe you're really good at the ML part and you can get the algorithms awesome to predict something, right? But maybe that means that you still don't know how to show your result to someone in a way that they can actually use that result to inform something. Maybe it's some health outcome or so on. Right. So I think what's nice about interdisciplinary work is that you can optimize in these little parts of this process or pipeline based on the discipline. But then when you sort of stitch everyone's viewpoint together, you just get a much better view on the problem, right? Because you can kind of address all these other issues of how can I make sure my data isn't biased or things like this? Maybe the person who's optimizing an algorithm hasn't thought about that in the same way as someone from another discipline. But then when you bring these two viewpoints together, then you're getting a much better way at solving the problem and looking at it and sort of filling gaps, right? So I think data science itself is just a very human process and it's very messy, and it's just because people are involved in every step of the way, you need more than one discipline. I mean, kind of like Luís and James said, you're addressing these very big problems that no one discipline can, sort of solve on its own. So I think it's just, that's what you need to really address really cool, big problems like Luís was saying, right? Otherwise you might as well just stick to your discipline and just, stick to optimizing and answering the very thing that you can answer.
I'll throw in an answer. Thank you for that. That was, there's a recent project where, where I was working with a computer scientist, a postdoc in our lab, and we were interested in basically, predicting new material properties. And so in this case, you get valuable properties. A property might be something can act as a vaccine against a disease. It can, kind of drug a certain disease-related gene. So both therapeutically or preventatively, or it could just have some valuable energy-related property like thermal electricity or ferroelectricity or photovoltaic capacity or whatever. So you can think of it as some huge matrix, and people have just basically, used data science style techniques, so deep and shallow embeddings, to kind of take literature and take prior experiments and kind of identify missing values in that big matrix of properties by materials, which ones will have these properties, which ones won't. And so in this particular case, I somehow was kind of thinking, oh, well, what are people actually predicting here? They're not predicting whether or not there's a value there. They're predicting whether a scientist will investigate that value and discover that it's there, and which is it's more narrow than what it actually is that they're claiming. There have been a number of really high-profile papers where people do that, but that's what they're doing. They're not predicting the presence or absence. They're predicting the likelihood that a scientist will investigate it and discover it. And so we thought, well, we could probably do better of both those things and their converse. So we could probably do better both discovering what it is that people will discover and discovering what people will not discover but are nevertheless promising if we incorporated people. And so we just, instead of just embedding, words in sequence and kind of like data as a result of reactions in sequence, we basically built these random walks, self-attracting, self-avoiding, and truly random, that kind of walked through papers as hyperedges via people or materials or properties. And so basically what that is doing is this random walks, billions of random walks, end up inscribing the likelihood that there will be people who will make the transitive inference that this material has this property, right? And and it turns out that if you just embed those streams as opposed to just words or just like experimental data, then just out of the box, completely naively, you get 100% improvement in predictions. In some cases, like COVID vaccines, you get like a 300% improvement, but it's a huge, huge improvement just by, in my case, it was kind of taking a sociological logic into consideration. And, and then you can do the opposite. You can actually turn the crank. Like you can use like Schramm-Lerner evolutions, which creates self-avoiding random walks to create predictions that humans would never predict, line them up with simulated predictions based on first principles, and it turns out they're no less likely to be predictable than the ones that humans are likely to create. So I think, you can, in this particular case, by understanding what you know, by incorporating factors that you have intuitions about being likely relevant, you can engineer them into data science pipelines that allow, again, kind of new insight. In some cases, it's marginal. In some cases, in this case, it was a big insight.
Right. Let me just provide a quick antidote to what I said before. I think you picked up correctly on what I was saying, that you can start with questions and find where data resources data science can be transformational. But we actually operate a lot in sort of the flipped sort of pathway, which is that I always try to do this myself, but I also charge with everyone that I work with. And at the Mansueto Institute, we have actually a staff member who's a data specialist who does this as part of his job, which is to be what I call a data strategist. So a data science strategist, which means that you ask for what are the great data sets or methods that are coming through the pipeline, and what could we possibly do with them that people are not thinking about. And I find that just a fun exercise, but I think it's often very productive as well. So an example of what we're seeing is, for example, a lot of high precision geospatial data. So we now measure the Earth, right, at like 24 centimeters or 28 centimeter resolution, on a refresh rate that's almost daily. It's going to become daily soon, on all kinds of multispectral ways and so forth. And so what can you do with that? A lot of people are launching satellites looking for applications. One of the things that we're seeing all the built environment. We're about to have data sets that are about all the built environment of Africa, which has never been measured before. That's changing very quickly. And it's through a combination of satellite data, machine learning, computer vision, super resolution methods, and a bunch of things that come together to do that. But then its analysis call for something that allows a different kind of urban planning that works with what is there and what are the processes on the ground, including people and communities. So there's kind of a lot of fun things that you can kind of unleash your data science imagination on if you know strategically what's coming up. So in that case, you start with the data and things that are being produced for other purposes.
Okay, excellent. Thank you. So I feel satisfied with the answers to my questions. So I'm going to turn it over to some questions from the audience, which we've been sort of collecting as you've been speaking. So the first is coming from Ian, who's going to ask the question himself. Ian.
Yes, thank you for the great discussion. And I feel like many great interdisciplinary works seem to emerge from very atypical collaborations or teamworks, where people from very different backgrounds get together and produce fascinating things. And I think all of you have made some great points about how do we collaborate with people from different backgrounds. But I think like for area career scientists, we also have the problem of how we form these kinds of atypical collaborations. And I wonder if you have any experience or suggestion to share.
Yeah, I would say one thing very quickly is, I think showing up. People are giving presentations and seminars everywhere, and I think just actually like showing up and learning about listening to a wide variety of things, and then venturing. If you have a pitch, I call it a pitch. So I would say very frequently sending out pitches to funders, but also to other collaborators, which are kind of like. It comes out of the Hollywood idea of where you're like pitching a movie idea. It's like less than a page, and it's kind of what you want to do and how you want to do it. And, it's like very few details, but it gets this idea across. And I find it's also fun to produce these kind of imaginative short documents. But, so one thing that one can do, and that I found success in doing, is basically pitching these things, pitching a research idea, and sometimes it's in the context of a grant, but sometimes it's not, and I think actually learning to be able to articulate in a very high level, succinct way the magic of what the combination provides is a recruiting tool, can kick off conversations, and helps you think and kind of steward these ideas towards like really building a group to take them on.
Yeah, I was just going to add, I really like what James said about having a pitch. In computer science, we call it the elevator pitch. You get in the elevator and you have like 2 minutes till you get to the top floor to explain what your brilliant idea is. Of course, in COVID times, you probably have a mask on and maybe you're not doing that. But I think in addition to that, in addition to what James said about like showing up, like meeting people, talking to people, and like bouncing ideas off people, I think it's also just sometimes collaborations come from the weirdest places. It might just be, maybe you're trying to recruit someone and you're in a hiring meeting speaking to someone, but you make those connections and you start talking about something that's very exciting, some of those bigger questions that Luís mentioned. And you just find that you have a connection with someone, and sometimes it just, it comes organically from that. And it's not someone you've just cold emailed and sort of found a connection with. Sometimes, even at UChicago, sometimes you meet people, a lot of us send our kids to the same school. And so sometimes I might meet another parent who happens to be in a different discipline, and then we could have a conversation and then eventually, realize we're doing research that could complement each other's. So I think it can be organic, but, when you're being a bit more strategic and you're reaching out to people, you have to also understand, just like James said earlier, sometimes it will succeed. You'll find someone, you'll make that connection, and it'll be great. And sometimes it won't. You don't have that connection, and you cold email someone, you think they're going to fit in really great with your grant proposal or project, and it just doesn't kind of work out, right? One piece of advice someone once told me was that once you find a good collaborator, hold on to them. And I would say that to you, is that when you do find someone from a different discipline, or even within your own field that you can collaborate well with, try to collaborate with them again, because it isn't that easy to find people that you work well with. So, if you find them, just realize that that's a good thing, and try to hold on to them.
Right. So I'll just amplify what both James and Marshini said, which is that you may have a pitch about things you're interested in, but also you should have a question or questions about, how do I do this? What can I do with this method? What could I do with that data? And surround yourself with people who you think are interesting. Go for tea, go for coffee, speculate, try to figure out what happens. So that's sort of at your level of people you know. But then I would be remiss if I didn't say that structures like CDAC or our own institute, Mansueto Institute for Urban Innovation, or the Knowledge Lab, and many other things on campus, that's what they want to do. They want people that have questions and methods and interesting things to come and talk to them and create community and sort of collective power around interesting questions. So the structures are there. Don't be shy. But you need to navigate them, be curious, and kind of both have proposals, but also have questions. What could we do with this?
So I want to ask Sarah Beery to ask her question now, because I think it's an excellent sort of follow-up and transition question from this conversation we're having currently.
Hello. So I had a question about the translation of your work from academic research to actual accessible and useful tools for the interdisciplinary communities you serve, and just what you guys have found works well and what doesn't work.
So this depends a lot on what the context is. Who are the people sort of on the civic side, or in policy and so forth. And I think that the answer is a bit contextual. There's no one size fits all. But I would say that the first thing that, at least in my experience, works is that you're always working within an ecosystem. Don't think you're sort of the data hero that shows up and has a tool and solves everyone's problem. I think people already are trying to solve the problem that you can help them with. And you have to understand how it fits in their routines and the way that they're seeing the world. And then, having understood that, you will be able to do a better job creating a tool or a method or a process that'll be helpful for them and that they feel they can actually use, and that will be therefore more transformational. So there's sort of a getting to know each other issue and understanding the ecology you're working in. And I think that often doesn't always happen. It takes time and trust and so forth. So we've worked with people like in slum communities who actually are producing data because they want to talk to policymakers about their problems in their own terms. That's a very powerful thing. But the first time I did that, I showed up with iPads and so forth, complete idiots, right? We had too much tech. We didn't have enough understanding of what we're dealing with. So that work is important. But I think once you understand the ecology, you often can actually completely transform it. If you understand why people are spending too much time or the problems that are running into the wall with, and if you can solve those and demonstrate then that you can solve them, then you can be the hero.
Yeah, I like what Luís said. It goes back to that, what I said a while ago, is that this is a very human process. And so I think context, like he said, is really, really important. But, I'd say like the other thing to note is that nothing is a snapshot. Things are changing all the time, right? So you often have to iterate. You might think you have solved the problem and been the hero, but things change all the time. So you just have to realize that you're just iterating and doing one iteration after another. And so a lot of this is about that initial showing up and then just making sure things are still working and that you're continually taking in feedback to kind of refine what you're doing, and realizing that it's not ever just done. Like, oh, okay, I've solved it. That's it. There's a vaccine. Okay, we're all fine. No, there's always like more that you can do and more that you can learn about the context and so on.
Just one addition, I think these are great answers, is that I think is underlying both these comments is that there's no magic bullet. It's like it takes real work to translate an idea, especially using a method or mechanism which is foreign to a community. Like it's a lot of work. And I think this is one of the reasons why, like Luís has whole arm of Mansueto that's dedicated to these extensions and to bringing stakeholders into the design of research so that they can help translate these things back to their communities. I mean, this is really hard. And often, my experience is it's nice to actually have multiple published outputs, because actually satisfying both of the kind of epistemic standards of both communities is often not possible. I mean, something is mundane from one perspective and exciting from another, but that exciting thing for this community is really mundane or even alienating from another community. And so I think from my perspective, it's extremely important work, but it's real work. It requires money and people, and it doesn't come for free.
Okay, excellent. So we've got just a few minutes left. We could field another question if the panelists are up for it. Otherwise, we can wrap up now, and people can take a short break before the next session. How are we feeling? Okay.
Yeah,
so,
happy to do whatever you want.
Okay, great. So James is hydrating, and we're gonna get Abby. We're gonna get Abby Stevens to ask her final question.
Hi, yeah, sort of a follow-up to a lot of these questions. I'm wondering what you guys think about training specifically at the intersection of fields. I find often that with data science, you are brought in, I'm a statistician. And so, yeah, I'm brought in as the statistician and then we have to adapt. So like maybe I have written something, in LaTeX, and then they're going to make me put it in Word or something. There's a lot of clumsiness and people stepping on each other's feet and things like that. And I'm wondering, is data science a discipline that deserves its own set of training requirements, separate from the individual disciplines that we're bringing together?
That's a good question. I think so. But I think that is evolving. What that is, what's its core, and how does it touch all these areas of application remains, I think, an issue. And I think you'll find different institutes and different universities and so forth will have different flavors because of their context of application. I think, in my experience and what I've seen a lot, even in things that were not called data science, is that you often may be called in as a technician to solve the technical problem of a field, because you know the math and you know how to code and you know how to deal with the data. You may like that, but then you're not the driver. You're sort of the technician, as I said. At the same time, I think it takes work, and you'll feel like you're being fit in a context where you're just, having to translate one thing into more sophisticated terms and so forth. That's definitely a living. But I think it's more exciting also, and there'll be always some of that. But it's exciting to think about what can data science really do sort of by changing how certain problems are addressed, or by really being transformational. And that does take making other people think like you, not just be in their service, but them being a bit more in your service, or it just being a collaboration. And I think that I'm not sure we're there yet. I think so that requires that data science has a status, and it's not just an assistant to other enterprises. And I think it would be interesting to keep on discussing that, but I think it's a tricky spot.
Yeah, I was just going to add that, I support what Luís said. And I also want to say that, I think it also just depends on you. If you're a statistician and that's what you really like doing, then, I don't think it's harmful to have some training that's sort of interdisciplinary or that's data science specific. But I think it kind of just depends on where do you want to be in this process. And like James and Luís, I also, and yourself, often, it does happen that you're oh, I'm the HCI person, or I'm the CS person, and therefore I have to do X. But like James said, you have to kind of figure out what is it that I like to do and that I'm really good at doing, and what do I want to do more of? So I don't think that it's harmful to have discipline-specific training or data science-specific training. I think it's more about what kind of role do you want to play? Do you want to be a translator? Do you want to stick to more what you like doing in your discipline or not? Right? But I think, like Luís is saying, it's not we really know right now. It's evolving. We're getting more programs like this one that are data science specific. but it kind of just depends on what you want to get out of it and where do you want to build those strengths out and what do you want to sort of evolve to be.
I'll just throw on one additional thing. I think these are awesome answers. But as an answer to the question of like, do I think there should be like a self-contained closed system of data science? I mean, from my perspective, no. And the reason is because of the no free lunch theorems. So, across all possible worlds, all machine learning algorithms are equivalently good and bad across all those worlds. And it basically means that there are a lot of secrets, which are associated with the production of data in a particular world, physical, biological, social, humanistic, et cetera, that are going to characterize the algorithm that's the most likely to intuit the pattern that is present in the data. And so I think in some ways, I think discovering a way, maybe data scientifically optimizable way of actually creating generative education where every excellent student is a new experiment is, I think, where we're going, right? I think the future of data science is not that it's not its own thing, but it's something that is engaged in, like optimized experimentation in collaboration with the intuitions that come from a variety of different fields. And it would surprise me greatly if like all of the intuitions from a certain area of condensed matter physics happen to be like the ones that provided the best intuition about, the evolution of whatever, like ancient poetry. I mean, I think that would be kind of implausible. So I think actually taking ownership of your education as an experiment is part of a critical element of the pathway to becoming a really path-breaking data scientist.
Well, we've gone a little bit over, but it was totally worth it. So I want to thank our panelists for joining us today. This was a really fun and interesting topic that's near and dear to all of our hearts. And I'm going to turn it over to Katie, who's going to sort of usher us into some lightning talks.
Thank you. And thank you so much to our panelists. I'm blown away by these discussions. And I can't think of a better way to wrap up day one of the CDAC Rising Stars workshop. So as we transition away from this central Zoom meeting to many other Zoom meetings, just wanted to kind of overview how that will work. I'm going to paste some resources into the chat. So as we heard this afternoon, we have some folks who have prepared spotlight talks. Those will be featured in this main Zoom meeting room where folks can hear 3 more sessions tomorrow morning. We have sessions on computational social sciences, many other really interesting session topics. You can check those out on the website. But we also have a majority of students who have prepared really fantastic lightning talks to overview their research. Couple ways for you to view that and network and interact with them. So in the chat, we have a directory that has every single Rising Stars information, all handed to us. Nothing is, with concerns of privacy and data, this was all handed over willingly. But there you will find their contact information, their talk details, including abstract and title, slides, a link to their pre-recorded talk as well. Most importantly, though, for this, you will find their Zoom meeting PMI or personal meeting ID code and a passcode. So the way that we're going to kind of virtually network without being in person is that each Rising Star will go to their Zoom personal meeting room. And then you can meet them there to either watch their talk, ask them questions about it, and engage with folks who are similarly interested in their talk area. We also have a Slack channel called Rising Stars _workshop. That is probably the easiest way for you to directly communicate with a Rising Star. You can follow up on questions from folks who had spotlight talks earlier and kind of keep the conversation going. So does anyone have any questions about that? I see that the chat got active. Great. Lots of thanks. Love to see it. And if you have any questions, feel free to send me an email, send me a Slack message. And just to kind of preview tomorrow, so we will be reconvening tomorrow morning at 9 a.m. Central Time. Apologies to folks on the West Coast that that's early for. But we will begin with opening remarks from Professor Nick Feimster, who is the CDAC faculty director. We will kick it off right away with 3 back-to-back-to-back spotlight sessions covering topics from security and privacy to computational social sciences, and then ending in very classic UChicago fashion, data science from theory to practice. And then we end the day with 2 fantastic panels, one on postdoctoral research in data science and concluding with careers in data science. So from here, we're going to kind of close out this central meeting room. Again, a huge thanks to our speakers and panelists throughout the day and our Rising Stars for joining us and being virtually hosted here at UChicago and at CDAC. So we will conclude here and I'll send you guys out for virtual networking.